Okay, so thank you very much for the introduction and for giving me the opportunity to speak to you. What can neuroscience contribute to economics? It's a perspective from somebody who is still enthusiastic, but at the same time, I would like to point out that the early enthusiasm needs to be modified and needs to be qualified, and you will see how. So I will argue that I will first show you what the neuroeconomic approach is towards understanding human behavior and the mind. Then I will talk about the core idea in standard economics, which is called the revealed preference theory, which is opposite to what neuroeconomics is doing. And then I will point out the key challenges we face if we want to influence the discipline. And I name them already now. It means that we need to establish an empirical link between neural variables and human behavior, and I will talk to what extent we have been successful in doing this. And we will need to provide an empirically grounded and tractable mathematical theory that captures the link between fundamental principles of brain functioning, the human mind, and human behavior. And note, we need a mathematical theory. It's not enough to have a box here and a box here and an arrow in between. That's not what we need. We need a fully fledged formalization if we want to change economics as a discipline. So that's what I say here in the last sentence. Only if 2 is successfully solved, then neuro research will have a major influence in economics. Now, what is neuroeconomics? Neuroeconomics is a relatively new academic discipline at the intersection of neuroscience, psychology, and economics. It's a foundational discipline, perhaps like physical chemistry, which led to important advances in chemistry, and biochemistry, which led to advances in the chemical underpinnings of biological processes. And when I say this, there is this hope that neuroeconomics is providing also foundations for economics and the social sciences, and that's the goal I think we should have, and I will point out what is needed to achieve that goal. The goal of neuroeconomics is to provide a microfoundation in terms of the underlying neural, computational, and psychological processes of how the mind works and how humans and animals make decisions. Now, what would or could be the consequences of deeper microfoundations of human mind and behavior in terms of neural functioning? Well, I think it facilitates clearly a deeper and more solidly grounded understanding of how the human mind works and of human behavior. And it can lead to better predictions how observable changes in the environment cause changes in individual and aggregate human behavior. And it also can lead to a better understanding of the boundaries between normal and pathological behaviors. One of my commentators, Ivat Levi, will talk to you about this. I think, and actually I have to emphasize this, I have gotten, when we started neuroeconomics, I've gotten invited to give keynote lectures at the World Congress of Psychiatry, which says a little bit that some of the things we do is relevant for psychiatry and for disciplines outside economics. Before I go on, let me sketch to you what is the economic approach towards explaining behavior, and I will contrast that with a psychological approach and then with a neuroeconomic approach. So the economic approach is very simple. So there are external environmental stimuli and preferences. What could these stimuli be? This could be incentives, informations, social norms. It could be price changes. It could be tax changes. It could be exchange rate changes. All the things that we experience in the external environment, and we want to understand how they affect behavior. Okay, and so as economists, we have here a strong focus on the role of incentives and belief about others' behavior. We traditionally neglect how the mind works, so there is no mind here in between these boxes. Okay, there's also no brain between these boxes where the arrow is. Okay, and when we go to psychology, and actually before I go to the psychological approach, so what we want to understand is we want to understand the mapping from X, which is the set of environmental variables, to Y, which is the set of economic or social behaviors. And the goal is to identify that mapping. So in very abstract terms, that is the goal, okay? Now, psychologists, they bring in some additional input here, which is the human mind that consists of motivations, cognitions, emotions. Some believe also in stable personalities and preferences. And traditionally, they have spent a lot of time in understanding how the human mind works and how that affects behavior. Now, the last step here is to bring another box, which is the brain. Not just the mind, but the brain. And that means the external environmental stimuli, they have an impact on how the brain processes this information. They have an impact on brain processing, on the interactions between neuronal populations. And the assumption here is that these neuronal interactions, they have a causal impact on how the mind works. And that then also affects individual behaviors. Now, if we wouldn't have that causal arrow here, if we wouldn't have these causal arrows, we could stop, because then the brain would not be needed. Okay, we need that causal arrow must exist, and therefore we put a lot of emphasis on discovering whether this causality is really existing, and actually it is. So we know now that if we, for example, reduce neuronal activity in specific brain areas, in particular in the lateral prefrontal cortex, we can change the willingness to pay for simple consumer goods. So people, you change how much they want to pay for something or how much they demand. You can make people more impatient. You can make them more risk-seeking. You can make them more selfish or less selfish. And we can even, by changing brain activity in the right prefrontal cortex, we can even change such complex things as social norm compliance. So basically you can turn somebody into a cheater or prevent somebody from being a cheater by affecting the neuronal activation in certain brain areas. And it's quite mind-boggling that this is possible, so that the neurons have directly an impact, a causal impact on such complicated behaviors. You can make people more or less altruistic. So this is really powerful evidence that shows that there is the neuronal activations and the interactions of neurons, they really have a causal effect on important social and economic behaviors. Okay, so that means a comprehensive understanding of economic and social behavior does require knowledge about the neuronal mechanisms and computations upon which the behavior is based. That does not yet mean that this is already relevant for economics. I mean, of course, if you want to understand behavior in its totality, then it's good to know what role the neurons play, what role the brain plays, but it doesn't help economists already to solve their problems, okay? And let me remind you of the goal of neuroeconomics. We want to establish a mapping from the set of environmental variables to the set of observable behaviors by identifying this function f here. And the key challenge to achieve that goal is that so how do we improve that understanding? Well, one way of improving this understanding is discovering new variables that have hitherto been neglected. So it could be, and that is one part of neuroeconomics research, that we find out that some seemingly unimportant variables, in fact, are very important in affecting behaviors. And why do we find out that? Well, we find that out through the research, okay? So we measure and include new variables that are suggested by neuroeconomic research, like neural firing rate, constraints on neural firing rate, response times, or even pupil dilation to our explanatory model. And we want to understand how these new variables mediate the relationship between X and Y. Now, kind of make it understandable what it takes to affect economics via brain research, it is important that you understand how economists have traditionally tackled the problem of understanding human behavior. And the economic model, as I said at the beginning, is very simple here. We assume that there are changes, there are always some changes in the environment, okay? We assume that there exists something like preferences or utility functions, and I say in a minute what that is. And these two things, my preferences and the changes in the environment together affect my changes in behavior, okay? Now, what are preferences? This is perhaps the most misunderstood concept outside economics about economics, okay? Because very often we economists use the language people maximize their utility. What do we mean when we say people maximize their utility? Okay, what we mean by preferences is that they are just a succinct mathematical representation of our behavioral inclinations. So, and we measure them through past behavior. So if you want to know my preferences, you would have to look at my past behavior and see what my behavioral inclinations are, and then assuming that my behavior has some stability, you know my behavioral inclinations, and then you know how the environment, you know also that how the environment changes, for example, how a price changes, you will know whether I buy more or less of a good, for example, okay? Now, when we talk about utility maximization, we do not literally mean that people maximize utility. It is very important that you understand that utility maximization is just a phrase. For example, if I prefer this water, which is perhaps still water, over sparkling water, we would give the still water a higher number to represent that than the sparkling water, and we would call it utility. We would just call it utility. We could call it something else. We need not call it utility, and this higher number represents my preference of still water over sparkling water. Okay? And in this sense, we represent behavior by attaching numbers to the objects, and the higher numbers represent, so to speak, a preference. Okay? And this is so there's maximization is just a sloppy expression that we use for something that is not really maximization. Okay. Now, that brings me to real preference theory. Okay. So what has been shown there is if choices obey certain plausible axioms, then we can represent them as the maximization of a utility function. But there's no maximization actually needed to go on. It's just a representation. And we say that people behave as if they maximize a utility function. So utility functions are merely convenient mathematical representations of behavior. So basically, to make that point really stark, in principle, for example, in sports, we order the best team is the first team. And so the first team gets assigned the lowest number. So who is the winner of the championship? The team that has assigned the lowest number, the first ranked team, okay? I could rewrite economics by saying, okay, the preferred alternative gets the lower number. And then we would say that people behave as if they minimize their utility. Okay? And nothing would change in economics if we would say people are minimizing their utilities. Okay? You just see how that is just a way of talking about things. It's not, we don't literally believe that people do some maximization. We just have a language that describes that, okay? So that also means that the utility functions have no existence of their own that is independent of behavior. And for example, sometimes we say somebody chooses a risky action because she has a preference for risk-taking. That's sloppy language that even we economists very often use. We say, okay, Michael chooses the risky option because he has a preference for risk-taking. It's the other way around, okay? He has a preference for risk-taking because he chooses the risky option, okay? So it's not the utility that has any substance that, or is a driver of behavior. Okay? Therefore, the utility or subjective value of a good is only revealed by decision behavior, and that means only behavioral data are relevant for economic welfare. There is no subjective value of goods that is independent of behavior, and in fact, subjective utility is a completely superfluous category that we wouldn't need at all in economics, okay? And so that's very important. That I think this is very often even misunderstood in psychology and also in the humanities and in the social sciences. People misunderstand systematically what the notion of utility means, and therefore I spent quite some time here. Now, therefore, the neuronal and psychological processes behind the behavior are completely irrelevant, because utility is, we don't need that term, okay? And okay, so the neuroeconomics approach is radically different from that economics approach, because the neuroeconomics approach basically postulates that subjective value is not the superfluous category. So now we use the term subjective value instead of utility. You could also use utility. In fact, we believe, and actually there is strong evidence for that subjective value indeed exists. It exists as a neurophysiological quantity expressed in the firing rate of neurons in particular areas of the brain. There's strong evidence from single-cell recording studies with monkeys that supports that view. And there are numerous human studies showing that subjective value representation in the human orbitofrontal cortex, or sometimes called ventromedial, VMPFC, ventromedial prefrontal cortex, exists. So value encoding, subjective value is, so what I described to you before is the economic approach, which liberated itself completely from psychology and neuroscience by making the notion of utility superfluous. But now, through neuroeconomics, it comes in through the back door, and actually, we have now scientific evidence that subjective value exists. It's not a superfluous category. No, the brain encodes subjective value. And actually, you do this constantly. There is evidence now. If you put people into a scanner and we show them objects, they almost automatically evaluate these objects permanently. We are constantly in an evaluation process, and the brain constantly evaluates what we see. You evaluate, for example, what I say. You evaluate my words, and so on. So this is one of the big achievements in neuroeconomics. Subjective value is indeed existing in the form of neural firing rates. Now, and in addition, we believe, although the evidence here is not as strong as we would have liked it, that subjective value is not only represented, it's also a causal determinant of behavior. There is some evidence here. So the downregulation of the human right dorsolateral prefrontal cortex with the technologies we have available for that, transcranial magnetic stimulation, for example, is correlated with the downregulation of this value encoding region and also correlated with large changes in behavior. So when we change behavior through these magnetic stimulation techniques, then what has been shown in some studies is that that change goes through these value encoding regions, okay? We also know that when these value encoding regions are injured, that we have a lot of behavioral dysfunction happening, and that's one of the areas in which psychiatry research becomes very important. So I believe that the insights on the neurophysiological basis of subjective value are major achievements of the neuroeconomic research paradigm. And we may ask, therefore, does that already help us to address the key challenge, providing a microfoundation of that mapping F such that better behavioral predictions result? Is that big achievement already helping us to change economics? And here I remind you what the requirements are in order to change economics. One requirement is that neuroeconomic variables, namely neural activity, neural connectivity, or response times, should improve predictions of human behavior relative to traditional variables, such as environmental changes or measured preferences. This is a task of empirical research. And second, we must be able to summarize and generalize these improvements by constructing better descriptive models of human behavior that incorporate the insights of neuroeconomics research. And that is the task of empirically grounded neuroeconomic theory that does not yet exist. It exists a little bit. There are a few people who do this. I will come to that, but we need much, much more here. Ideally, this theory not only helps us understand and better predict behavioral responses, but it also helps us to understand and better predict brain responses. Now, can we meet these requirements? Well, with regard to the empirical task, new variables, better predictions, there are promising results. So one comes from my commentator, Ivad Levy, has a very nice paper where they put people into the brain scanner in an fMRI scanner, and they let people watch passively consumption items. So no choices involved, okay? They just passively watch consumption items, and they record brain activity in the value encoding regions of the brain. And then they take these items and pair them in many, many different ways, and people have to make choices subsequently. And now they take the brain recordings from the passive viewing part to predict people's choices in the choice part. And notice, according to the standard economic approach, when people passively view something and do not make choices, there's no such thing as utility. There's no such thing as utility. Utility does not exist independently of behavior, independently of choice. But what they do is something different. They take the passive viewing stage, when people do not make choices, and look at these brain responses in the subjective value encoding regions, and if these regions are really informative, if that brain activity is informative, encodes subjective value, then it should predict their choices, and it does predict their choices much better than chance. So this is a very nice paper that shows that it can be done, and that these subjective values do have predictive power. And there's another paper here by Smith et al. They take neural activity. It's very similar. They also take neural activity during passive viewing of food items, and they predict subsequent choices of paired items. A similar paradigm, although not quite the same. Now, so the empirical task can be done. So, and there will be more coming, and I'm very hopeful that we will make progress here in this area. Now, the next question then is, are neural data better predictors than behavioral measures of preferences? I mean, the question you get when I tell an economist about the passive viewing thing, then the economist responds, well, but do you really do better than what we already can do with our behavioral variables, with our preference measurements? And in order to make a point in favor of neuroeconomics, we would need to do better. Okay, and the question is, do we do better? And here, there's not enough evidence to make a general statement, but positive examples exist, and I can tell you some of my own research. It's a joint paper with Burke, Williams, and Tobler. And what we do is the following. We have two tasks. In task one, people make choices about income distributions between themselves and another individual. It's about $20, basically, and so people can accept or reject income distributions like 1 for me and 19 for you, or 18 for me and 2 for you, okay? And so on. So we basically, and that's done in the scanner, okay? So we have two measures now of preferences for income distributions. One is a neural measure that comes from the brain, and one is a behavioral measure that comes from the behavioral measurement, okay? And then we move to task two. In task two, people have the chance to vote in favor of redistribution from rich to the poor. And everybody is from time to time in the position of a poor individual, and everybody is from time to time in the position of a rich individual. And the interesting question is, do the rich individuals favor redistribution to the poor, because when they are poor, everybody who is poor favors redistribution to him or herself. Okay, so that's clear. But the key question is: do the rich, those in the rich position, favor redistribution to the poor? One interesting result is here, by the way, that women are more in favor of redistribution. So, but the question here again is that whether the neural or the behavioral variables from stage 1 are the better predictors. Okay, and what we find here is that the neural variables are indeed much better predictors. Okay, so basically. We find I don't go into the details. If you have questions, we can do this in the discussion. But the neural predictor from task 1, the neural predictor of preferences for income distributions, is a much better predictor of voting behavior in task 2 than the behavioral predictor. Okay? So now, will such results like predicting choices from passive viewing brain data, having examples that show that neural predictors of preferences are better than behavioral predictors, will they already convince economists that this is something that we should teach, that we should do, that should be part of the normal curriculum of normal practice in economics? Well, the answer is a clear no. And the reason is this: showing that specific brain activity is causal for specific behaviors, that specific brain networks implement particular computations, that neural variables predict better than the standard variables used in economics, etc., etc. Showing all these things generates useful knowledge but will not help economists to solve their problems. Okay, that's the key. So if you want to influence that other discipline, you have to solve their problems. It's nice if you come up with new problems and say they are interesting. Yes, they are interesting, they are exciting, okay? But you have to solve their problems. And that's not what we do here. So what is needed then to move economics? Well, to move economics, the computational insights gained from neuroscience and neuroeconomics must be translated into tractable models of behavior that are useful for solving economists. And we need what I call a theoretical bridge between fundamental principles of how the brain constrains the human mind and general descriptive models of behavior that generate predictions across a broad class of situations and that help us solve important behavioral problems. So the second thing is important, this theoretical bridge building, and that has not yet been done really. Now, let me pause a little bit and ask, is neuroeconomics on the wrong path? Well, the answer is yes. To the extent to which neuroeconomics aims at changing or being useful for economics, I think the discipline is on the wrong path. And what do I mean by this? I mean by this the following. At least 90% of neuroeconomics is currently not dedicated to what it takes to move economics. It's dedicated to brain imaging, to brain stimulation, to all that kind of nice things that I described to you and you can get excited about. But that is more part of neuroscience than economics in some sense, okay? And actually most people in neuroeconomics don't have the perspective of economists and do not even know what it would take to move economics. That's my claim. So if you go to a annual meeting of the Neuroeconomic Society, you have 80 or 90% of people who do different things than the ones that I describe would be necessary to move economics, okay? And what now then, when we are in that situation, are there at least a few positive examples? Yes, there are, of course. And one positive example is that I want to bring is the notion of efficient coding that plays a big role in neuroscience. And it is this idea that the brain has a limited processing capacity. And so when we get external stimuli, when we see external stimuli, they have to be processed in some way in an efficient sense because we have limited capacity. And that puts constraints on what can be processed and how it is processed, how noisily it is processed, and so on, okay? And so, so basically, the theory of efficient coding provides general principles of how the brain constrains internal representation of environmental stimuli. And that is of immediate importance, at least in the abstract sense, okay? What does it mean? Well, how we perceive stimuli, such as risky or intertemporal prospects, is immediately important for behavioral theories of risk-taking, okay? Or for behavioral theories of intertemporal choices. And it has also been shown that the theory of efficient coding is a very good basis for explaining reference-dependent behavior. And it's very easy to see, I mean, when our neurons, with a light example, when we are adjusted to a black room, to a dark room, then our eyes are adjusted to darkness. And then when we see a light, immediately then we have problems in the first moment to see because it's too bright for our eyes. So basically because the neurons, they are kind of hooked, neuronal functioning is hooked on this other situation, the dark room. And this generates what we call reference-dependent behavior. And this is, of course, has been documented over and over again in the behavioral sciences, in psychology, that our behaviors are reference-dependent. And the theory of efficient coding can make a lot of sense of the existence of reference-dependent behaviors. Now, let me give you two very concrete examples. One example comes from people such as Paul Glimcher and all the other names here, Ryan Webb, Louis Kenway, Agnieszka Timula, they were all lab members of the Glimcher lab. They have kind of focused on this idea of divisive normalization as one potentially promising approach of capturing efficient coding principles. And here you see one possible way of doing this. So on the left-hand side, you have subjective value. On the right-hand side, you have here the neurons that encode the option value of option 1, but you have also neurons that encode the option values of the other options, and that there is a particular mathematical relationship according to that theory that constrains basically what we do. Okay, and they have shown that they can rationalize certain anomalies relative to standard economic theory in theories of risk-taking, for example, with that approach. Another approach is related to our moderator this evening, Michael Woodford. I've written Woodford et al. Because you have many co-authors, but basically the idea that Michael is pursuing is partly based on papers like the one by Wei and Stocker, and this Wei and Stocker paper is itself based on the theory of efficient coding. And the idea here is that sensory stimuli have noisy internal representations. So whatever I perceive gets noisily represented in the brain, and then we make there is a mechanism that makes inferences about that noisy representation, and it can be shown that this generates particular biases in how we perceive the world. There are many visual illusions that can be rationalized in this way based on the principle of efficient coding. And the hope is that we can also derive, and actually Michael does this already, he shows that similar approaches can be used to explain very important facts in risky choice behavior in like risk aversion, loss aversion, and probability weighting. And he can rationalize fundamental patterns in risky and intertemporal choices. Actually, this is not because I'm now at Columbia giving a talk. It's really my honest opinion. I think what Michael is doing is at the frontier here, and is, in my view, by far the most promising, what we currently have, because it's exactly addressing what I'm saying. Constructing a theoretical bridge between basic insights about how the brain works, how the brain constrains our perceptions, uses mathematical formulations, brings them at the behavioral level, so kind of imports them into behavioral theory, and shows how behavioral theories change if these principles are operating. Okay, so that brings me to the end. Brain functioning and neuronal activity have important causal consequences for human behavior. The brain behavior link is still incompletely understood, but important progress has been achieved. Examples are subjective value has a neurophysiological representation in specific brain areas. Brain activity in non-choice situations predicts choice behavior. Brain activity sometimes is a much better predictor of out-of-context behavior than behavioral preference measures. But in order to really affect economics as a behavioral discipline, we need empirically informed, tractable, and testable models that connect the level of neural and mental processes underlying decision-making with the descriptive properties of behavior as modeled in economics. Thank you very much for your attention.